Hello. Hey, we're looking at section 2.2, working with the shortcuts on derivatives. So this follows day 1 of 2.2, and we're going to go to example number 4, evaluating the derivative at a point. And we've done this a little bit where we looked at what is the derivative at a point. So that's what we're trying to find. And I'm given over here my equation, my original equation. So now let's try to see if we can take the derivative. Using the power rule, I get f prime of x is equal to, power comes down, and I'd have 3 times 3 is 9, x squared. The next thing would be minus, the derivative of 4x would be simply 4. So I have my derivative written. Now I'm going to evaluate it at a point. And that point is at -2. So this will be equal to 9. We're going to take the -2 and square it, subtract 4, which that looks like it'll be -2 squared is 4, so I'd have 36 minus 4, pretty steep slope of 32. So f prime of -2 equals 32. That's part of what we need. Remember, we were trying to, that's all, I guess that's what we wanted to do. What is the instantaneous rate of change? The instantaneous rate of change is 32. Instantaneous rate of change stands for the derivative, the slope at a point. B is sort of similar. We will take the derivative of this function. I see those radicals, so I think the first thing I'm going to opt to do is rewrite this using rational exponents. So I'm going to call that -4 x to the 1/2 plus, I'm going to bring out that coefficient. See the division by 2, I'm going to call that a 1/2 instead. And this will be x to the 3/2, power of 3 square root. So 3/2. And let's take its derivative. So f prime of x would be equal to, the power comes down, I'd have -4 times 1/2, x raised to the, subtract 1, that'll give us a -1/2 power, plus the next term, go ahead and take the derivative of it. I'd have 1/2 times 3/2 comes down, and then I'd have x to the 3/2 minus 1, so that would leave me a positive 1/2. And now I think let's just clean this up a little bit. -4 times 1/2 would be -2 over x to the 1/2. We could rewrite it as square root if we wanted to, plus 3/4, and then square root x, instead of writing it as x to the 1/2. That's fine. Now the task, actually, this remember is called the general derivative. And now we want to evaluate f prime of 4. And I'd have -2 divided by square root 4 plus 3/4 of the square root of 4. That gives me -2/2, or -1, plus 3/4 times a 2, which makes that -1 plus 6/4. We're getting there. That's -1 plus, what, 3/2 if we reduce. Looks like we will come out with a positive 1/2. The slope at 4 is 1/2. Next problems. This is what I was thinking we were going to do for the first one. This one actually wants us to write the equation of the tangent line at the given point. So my given point is going to be x equals 1. And we know that we need 2 things if we're going to write the equation of a tangent line. First off, I'm going to need a point, and I'm also going to need a slope. Correct? So what is the y value when x is 1? Essentially, we were just trying to find 1 comma what? Well, that I take into the original equation, so I'm going to look at the function evaluated at 1. I'd have 3 times 1 squared is 1 plus 1 minus 3. Just following the f of x rule there. And that would be 3 plus 1 minus 3. Looks like we are getting what? 1. F of 1 is 1. That would be an ordered pair then of, I'll write this where I can see it, 1 comma 1. So we got our point. Now we need to get the slope too. I see here it says draw the tangent line through 1 on the graph at the right. Okay, we can do that. Estimate your tangent line coming through there. Mine touches a little bit more than it should. I want that, you know, just skimming by. Let's see if I can raise that up a little bit. Yeah, it's kind of hard because it's kind of vertical there. But there's our best look at a tangent line. And next thing we want to do, we need to get the slope. So let's get an f prime going. F prime of x equals, well, this won't be too bad. What's the derivative of that using power rule? 3 times 2 gives us 6x. The derivative of x is 1. Now let's evaluate that at the point 1, because I said let x be 1. So I'd have 6 times 1 plus 1 takes us to 7. F prime of 1 is 7. To write the equation of the tangent line, that's going to be a y minus y1 equals f prime evaluated at x sub 1 and then times x minus x sub 1. All right, so remember we have our ordered pair of 1, 1, so it's going to be a y minus 1 equals, our slope was 7, and then I'd have x minus 1. And that is just fine to leave that as our answer. You do not need to put it into slope-intercept form. And finally, number 6, determine the points, if any, at which the graph of the function has a horizontal tangent line. Well, first, just thinking out loud, horizontal tangent lines have slopes that are equal to 0, correct? When I look over at the right and I see this cubic equation, because I can see we're on a cubic, I can see 2 spots where I think it's going to have horizontal tangent lines. How about you? So let's draw those in. I would expect a horizontal tangent line there, and I'm expecting a horizontal tangent line at that value. Let's see if we can find them. All right, so f prime of x is equal to 3x squared minus 10x plus 7. Use that power rule. Now, evaluate this. Oh, now we need to find where f prime is equal to 0. So let's take our derivative, set it equal to 0. And I think this is going to be a factoring. I can tell that I probably should have 2 solutions since I'm working with a squared function. And let's see if we can find those 2 solutions. So essentially, I want to go into factoring, right? Factor on the right. And that's going to give me 0. And you might say, oh, I hate those ones that have lead coefficients. But our lead coefficient, it couldn't be more nice, could it? 3. And then we got the 7 at the end. Those are pretty darn nice numbers. Why is that? Because they're prime. So the only thing that multiplies to give me 3x squared is a 3x times an x. And the only thing that multiplies to 7 is a 1 and a 7. Now I just got to carefully place that. I'm going to put the 7 there and a 1 there. Because I have a plus sign, I know that the signs are the same, and I look forward and they are negative. So these both have to be negative signs. And I believe that works. There's that negative 7x followed by a negative 3x. Those sum up to negative 10 for our middle term. All right, now let's take each individual factor and set it equal to 0. And this is where we are coming in with those two solutions. So 7 equals 3x, or x equals 7 divided by 3. Over here, add 1, and it looks like x equals 1. And I'm going back and rereading, determine the points, if any, at which the graph has a horizontal tangent line. The graph has horizontal tangent lines. Tangent lines at x equals 7/3 and also at x equals 1. And that's because f prime of x equals 0 at these values. It's always nice to have your reason why you're able to get that solution. And I think that's about it for the notes today. That takes us into the homework piece, which is this worksheet on derivatives. Keep in mind, when you take the derivative of pi, pi is a number. That's kind of like saying f of x is equal to 3.1415 squared. That's the derivative of a constant, isn't it? So I think you'll know what the answer is to that. A lot of these are going to have those tricks that we talked about yesterday, where you might want to rewrite this first and bring that exponent up to the top. Now go into your power rule, so y prime equals. Here I'd simplify down my x's first and get this as 6x to some power. Think about how you work with these powers. You got 3/2 over 1. Yeah, there's just lots of little tricks on this example. Okay, good luck. See you later.